Hi everyone, we're Team Teach Steve Code.
I'm Jack.
I'm Chris.
I'm Audrey.
I'm Josh.
I'm Tim.
I'm Xiao.
Over the past 2 semesters, our group has been working on a project called Modding for Minecraft, sponsored by CodaKid, a Scottsdale-based academy that teaches children 6 to 14 about Java programming and game design by modifying Minecraft source code.
Our sponsor, CodaKid, is an academy that offers a variety of after-school classes and tech camps that teach kids about computer programming and game design. Our main point of contact was David Dodge, who is the founder of CodaKid, and we met up with him every 3 weeks or so to catch up on our progress and demonstrate our work to him. Since Minecraft's code is open source, modifications to the game can be made and injected into gameplay. CodaKid leverages this to show students the power of software development. In their after-school programs, students go through the process of writing code to modify the Minecraft game. Their code introduces vehicles, new armor, and stronger enemies. This shows students the power of software while learning key concepts of software development. Over the past 2 semesters, our group has been developing a number of different tools for CodaKid.
Part of these involve helping CodaKid be able to set up for their classes better. That was using installers. These installers are software packages that with 1 or 2 clicks, the CodaKid staff can set up a computer and configure it for usage in one of their classes. This has a number of applications, from resetting the computers between lessons at the CodaKid facility, or establishing and setting up a computer at an off-site location, or as they move into new types of ventures, being able to send these over the internet to people taking their classes from afar. The second deliverable of the project was developing lesson plans for CodaKid to use in their classes. These consisted of a template for a mod, a lesson plan for the teacher, and the code package that the students would then modify. Through these modifications, they would then learn how to develop the mod on their own and be able to put it into their gameplay. This is the basis for how CodaKid teaches their students.
The first thing on the list of deliverables that CodaKid gave to us were that they wanted installers for both the Windows and the Mac platforms that would contain a package of programs for teaching kids code via creating Minecraft mods. Some of the programs that we needed to package were Eclipse, the JDK7, Forge, GIMP, and Paint.net, with 2 versions of the installers on each platform.
For the Windows development, we used an open source program called Inno, which is based in the Pascal language, which allows other executable programs to all be packaged into one single executable. For this, we ran through the executables of each program in the CodaKid installer, and then used the Pascal scripting language to move and set up environmental variables, move software packages around, set up the folders necessary, unpack templates, and other lesson plans. On both the Windows and Mac platform, we have 2 installers. The first one contains all the executables, packages, and data locally, which can be used for in-person setup, either at a remote location or the CodaKid facility. The second is an effort to work for their asynchronous class, which will be taught online. For this, it would be difficult to move a gigabyte file from the CodaKid server to each different person taking the class. For this, we leveraged online link downloading to be able to go out to the developers' websites of these different programs, attempt to download the link from their website, and then install. And if that fails, then it's downloaded from the CodaKid server. This limits the bandwidth necessary for CodaKid and allows for more students to take the class.
And the Mac version does a very similar thing. However, it's built using an open source program called Packages that's GUI based with the ability to run scripts.
The first of the mods that we created was a lava bomb, which acts as a normal TNT except it blows up into lava, as you can see here. The kids could customize the radius of the explosion, as well as the time that it took for the bomb to detonate in this mod. The next mod that we created is a lava creeper, which is similar to the lava bomb except it's a hostile entity that explodes into lava. One of the functionalities of the creeper in the Minecraft game itself is when it gets struck by lightning, it becomes supercharged. So we made a supercharged lava creeper where a normal lava creeper is exposed to lava, and they will do significantly more damage by exploding. And again, kids can customize the destructive power of the lava creeper by changing its explosion radius. Next up, we have the item launcher, or just the launcher, which is a projectile-type weapon that launches explosives. And here we're actually demoing two mods, the second of which is the camera launcher, which allows the player's point of view, the camera view, to follow the path of a projectile. And here you can see the camera is moving along the explosive as it falls. The last mod that we are demoing is the car, which is a vehicle-type mod that we made from modifying the Minecraft's boat functionalities into a land vehicle. The car is more complex in terms of design because unlike the other four mods, we had to create a completely new model for the car from scratch, and that involved learning several modeling softwares that we'll be touching upon later in the video. While some of the movements are inherited from the in-game boat, we came up with our own functions, such as traversing up and down blocks of terrain. In terms of customizability, the kids can change the appearance of the car, the speed, the durability, and all that.
Many of our mods use functionality from existing Minecraft classes to focus on specific programming concepts we want to teach students, while also leaving room for them to customize features and really make the mods their own.
When we're looking at bringing something entirely new into Minecraft, because certainly Minecraft has many things from animals to monsters to vehicles, but when we want to make something truly our own, we actually have to build that ourselves. So a lot of what I did in creating these was to go in and build models out of blocks in a software called Techni, which exports these models in a way that Minecraft can understand. Now if I were to just do that, you would get these kind of ugly white boxes which look like things but have nothing on top of that. So the next step is to use any sort of painting software like Paint.net or GIMP were two that we used to draw pixel art that would then map onto these models in a way that really brought them to life. And this was something that, in addition to providing something ourselves, kids could also come along and, style them, color them in their own way.
So on the graphical side, what I did was I took all of these art components and I put them together and integrated them into the Minecraft game, such as making sure that the models that we made ourselves would render in the game and creating two-dimensional pixel art for the items when they appear in Minecraft. And more of the fine details of the graphical elements included tweaking the sizes of these models and their positions and how they appeared in the Minecraft game to make them visually pleasing as well as for the children.
So you can see that throughout the process of creating this mod, it sometimes can be very difficult and very technical. So sometimes it takes a long time to explain to the student, especially when they are so young in the age of 7 to 14. So we come up with, for each mod, we come up with lesson plans. And these lesson plans gonna use in the classroom, where the teacher gonna use them as a guide to communicate to the student and how they want to teach, what we want to teach them throughout the mods. And this gonna help them with all kind of technical issues and troubleshootings and all of that.
Over the past year, we as a team have learned many important lessons, both technical and non-technical. One of the important lessons that we learned is how to work with a startup company like CodaKid. Initially, we experienced difficulties with communication on exactly what CodaKid wanted in their deliverables. Along the development of the project, we had to adapt to changes in the deliverables, and to deal with these changes, we had to adopt an agile process.
So to be able to adapting the agile process, we as a team actually have to use some kind of version control where we can have to put our projects together, and we have used and learned how to use Bitbucket Also, as a team, we learn how to like organize our tasks based on that and putting priority and requirements before the deadlines, making sure that we're giving as much support and as much feedback to our sponsor with a better quality of our program, our projects.
Certainly over the last year we have gotten a lot of work done, met a lot of different people, and we certainly, even though it's a big team, could not have done that ourselves, so we have some thank yous to put out there. First of all, for Professor Mayron last semester for overseeing the first half of this project, providing some really important feedback that helped set this project off on the right foot to start out with. And also this semester for Silex and Gupta to step in, try something new beyond the learning curve, and really just continue that on and give us good feedback on what we should be doing.
In conclusion, Teach Sleep Code would like to thank our sponsor, David Dodge and CodaKid, for this incredible opportunity to learn and work alongside an exciting, fast-growing company, with the goal of making programming a more fun and educational experience for children. We would also like to thank the students at CodaKid for playing our mods, and we hope you all enjoyed our work.